Good morning, good evening, knowledge seekers and executors. Welcome to my channel. I'm going to talk about the extension of the microservices design patterns. So far, I was talking about service design pattern and database design pattern, fault tolerance pattern. Today, I'm going to talk about the further today and further videos going to talk about the other patterns like scalability pattern, deployment pattern, and your observability pattern, security pattern. These are all the patterns which are predominantly used to make your web services robust and more maintainable. So let's go with that scalability patterns. See, basically scalability patterns in microservices refer to the design approach for the microservices architecture that enables system to handle the traffic and workload and user demands effectively. So the traffic you can understand, like if you go outside, like by going by car, like you can see a lot of signals will be controlling your traffic, like people can go straight or right or left, that can be controlled by your traffic signals. The same thing like here, your microservices will be used by multiple teams, multiple consumers, or like even you are one of the consumer to other services. So all your requests and responses will be handled by this particular controller. So how do you control it and what basis you can control it? There are design patterns inside the scalability pattern which I can talk about. The first one is like horizontal pattern, vertical pattern, and bulkhead, load balancing, and shading pattern, auto scaling. All these are all part of the scalability patterns. So first we can talk about horizontal scaling. Horizontal scaling pattern involves adding more instances of a service to handle increase in the load. By distributing the workload across multiple instances, horizontal scaling improves performance, fault tolerance, and allows for elastic scaling based on the demand. So predominantly horizontal scaling will increase your size of the your hardware. So basically what it will do, like the moment you increase it, it will be faster. So consider like comparatively your 512 MB or like 256 MB laptop, or like 512 MB laptop or 1 GB laptop, you can see that differences between the performance. So the same way, the moment you increase that memory, automatically the performance will increase it. The same thing happening for the horizontal scaling. The moment you increase the size or related to the terms of the horizontal purpose, then it will increase the performance and increase your microservices performance also. That is what your horizontal scaling. Vertical scaling pattern increases. The second one is vertical scaling. It will increases the resources allocated to service such as CPU, memory, or storage capacity to increase the load on single instance. It's a single instance. It's not like you are additionally adding things. You're not additionally adding the service. You are increasing the same server which has been increased. So if for example like I was talking about horizontal scaling, it's like increasing, right? It's like increasing the you have one laptop which is doing the same work, and if you increase multiple laptops, automatically your performance will increase. Here the same laptop is having the example which I told you, like one particular mobile which is having the same mobile, if you increase inside the processor, automatically your vertical scaling will increase it. So you are not additionally increasing your servers, you are increasing the memory, CPU, all these things for the same server. So vertical scaling can be useful when a service requires additional computational power and when the workload is not easily distributed. So basically the distribution purpose is like whenever the load has been increased, automatically your service performance will reduce. So automatically it will come down. So to make it up, you have to increase your heap size or like CPU or memory, all these things. If you increase, it will done. That is vertical scale. Sharding is one of the pattern. Data horizontally distribute it across multiple services. Each shared services, that's what people are calling. Shared contains a subset of overall data, allowing for efficient data retrieval and parallel processing. So parallelly, it will processing all your requests. Shared enables scalability and improves performance by dividing the data load among multiple services. Basically, shares, it's talk about parallelly you are increasing your resources. So that is what it will do. Horizontally, it will distribute the load across multiple services. The moment you parallelly increase it, parallel request, take the response and take the request and process the response. So predominantly that will make your performance of the service. Thank you so much for this video. I'll talk about remaining patterns in my next video.